All right. So our target is to do this peering, this router and that router. We want to pair them. And because they are in different ASs, obviously it's going to be eBGP. It's going to be eBGP. But before you pair, the first thing is to test reachability. It's key. So on R1, the point is, do we want to pair using the interface? Let me capture this. This R1 and R6. We want to pair using this interface, or we want to pair using the loopback. The decision is ours. Now, first, let's see how we can pair using the bare interfaces, okay? So using the bare interfaces, we have reachability straight away. So on R1, let's ping the interface facing us. We're pinging 10.0.0.6. And there's reachability over here. So we can pair. So let's go. Configure terminal, router BGP 50. Our neighbor, we are using that bare interface, which is 10. The one we just pinged, 0.0.6. And it's in the remote AS of my M key is not typing, so I'm developing a strategy. There we go. Remote AS of 100. You see, our peer is in an AS of 100, and that's what we just entered. Let's go to the R6 to do same. On R1, before we even configure the R6, let's do some verification. So this commands show BGP, show IP BGP. Summary. And show IP BGP and show IP route. We are going to use these commands extensively. What do they mean? BGP will keep 3 tables. BGP keeps, just like OSPF, it keeps 1, the neighbor table. It also keeps the topology table. And it keeps the routing table. The difference is, neighbor table will tell you the routers which have formed neighbor relationships with the router on which you are. Okay, so this one will give you an information on the routers that you have become neighbors with. Topology table will give you a database of every route that you have received, all the routes that you have received. Now, all the routes that you have received, the best one, we have some which are not best, some are better than the others. The best one will end up entering the routing table. So routing tables are for the best routes. Okay, so take note. All the raw data will be here. So routes to every network will be in the topology table, but the collection of the best ones will be in the routing table. Now, if you want to see the neighbor table, use this command. If you want to see the topology table, use this command. And if you want to see the routing table, you use this command. So let's take note. Now we have configured a peering command on R1. So let's use this command here to see whether we have a neighbor. On R1, show IP BGP summary. And you see, we have this information here. We are seeing a neighbor here. We are on R1. The R1 IP is .5. We are seeing a neighbor .6. And watch here. The state is idle. The state is idle. This is not a good news. Why? Because if routers, BGP routers should become neighbors, the state will move from the idle state to the active state to the open sent to the open confirmed before finally establishing. So this is the initial step. The routers haven't become neighbors. So anytime you are doing your troubleshooting and you issue this command and you see the idle at the end of the output, just as we are seeing here, you shouldn't be happy. Then it means there's something wrong. So let's go to R6 to effect the commands. So on R6, we are also going to pair with the interface. Configure terminal and router BGP. This one is in the AS number of 100. So we choose 100. Then our neighbor, we are pairing with the interface of the router in the AS number 50. As I said, you have the option to pair either with the loopback or the interface. But this time we are using the interface, which is .5. So 10.0.0.5. And remote. Oh, sorry. I was trying to use my trick and it didn't work. Okay, so neighbor 10.0.0.5. Remote. Remote AS, and it's 50. The router in the R1 is in the AS number 50. So we enter. And let's see, what do we see? Good news. So you see this output here shows good news. We have just discovered a neighbor. You see, the command was so simple. Now let's go back to R1 and see whether we are still in the idle state. So push up the command. We want to see our neighbor table, and the idle is gone. The idle is gone. So we have a neighbor. If you see this, it means good news. Okay, you have a neighbor, but you haven't received any prefix from your neighbor. If I say prefix, your neighbor hasn't advertised any network. Okay, so it's good news. Most of the time, look out for the idle. If it's idle, it's not good news. So on R12, let's see whether we have a neighbor. Show IP BGP summary. And we have a good news here. So is it pairing with the interface is so simple. Pairing with interfaces is so simple. Nothing more, nothing less. But there's something here. We have just formed an eBGP relationship. And as a rule, eBGP relationships, for routers to form eBGP relationships, the routers should be directly connected. That is the rule. So these two routers that are forming eBGP relationships, they're directly connected. So we don't have any problem. It's a rule. That doesn't mean if they are not directly connected, they can't become neighbors. We have a way of going around it for them to become neighbors if they are not directly connected. Okay. So now we have abided by the eBGP rules. One, we have ensured that there is reachability, and we have configured just the simple commands on router 1, router BGP 50, neighbor 6.6.6.6, remote AS 100, just this one. And they became neighbors. We did the same on R6 and they also became neighbors. Now, you see, peering with interfaces, you see how easy they are. Let's see whether we can peer with loopback interfaces. Let's see how we can peer with loopback interfaces and note the difference. So I'm going to delete the OSPF, the BGP configs. I'm just going to config conft R6 no router BGP 100. I just took off the BGP process from R6. Let me go on R1 config T no router BGP 50. I just took it off.
What was the question?
Okay, Thomas.
Please, are we saying that we can, is it possible to pair with both the BGP and the loopback at the same time?
Is it possible to pair with the interface and the loopback at the same time?
Yeah, is it possible? Yes.
No, it is not. You have to choose one.
So which one is more suitable, please?
Okay, the best is to pair with a loopback interface. That's the best. And we'll find out why as we move on. We'll find out why pairing with loopback is better than using interfaces. Okay. All right. So now there's no BGP session. Let's see. Show run. Let me pipe it to section BGP. And there's nothing. Okay. Show run. You pipe it. Pipe is something like filter. You don't want to see all those plenty output. So section, this output here, this one here is piping. Okay, you are filtering. You want the BGP section to only show. Else, without that, just show run alone. You see, you have all these output here. We don't need that. What I'm looking out for is the BGP section. And now we don't have any BGP section. So we are coming to pair using loopbacks. And 0.0.4, 5, 6, and the loopback of this one is 1.1.1.1. You remember loopback 0. And the loopback for this one, also loopback 0, is 6.6.6.6. That's what we have chosen to pair with. Okay, we have several other loopbacks, but we want to pair with this loopback and that loopback. So on R1, we should be able to be reachable. Okay, we should be able to reach this IP address, reachability. I'll call it the rule of reachability. Okay, the rule of reachability. And whilst we are on R6, once you're on R62, you should be able to reach this loopback IP. So let's go on R1 and ping 6.6.6.6. We're on R1, we ping 6.6.6.6. Bad news. There's no reachability. So you don't even have to attempt configuring BGP. It will not work. It will not work. Why are we not reaching the loopback? Loopback addresses are always considered to be behind the routers. Okay, that is a rule. Even though we have configured a loopback on R6, but it is this IP here is considered to be behind the router. That's why you see this arrow. Okay, it's a perception. It is perceived that the loopbacks are addresses behind the router. That is why we are not reaching this one. So what do we use to achieve reachability? Remember, if the routers are directly connected, we don't have any problem. 2, we can use static route to achieve reachability, or we can use IGP. IGP is the routing protocol. That's OSPF, ISIS, EIGRP, and RIP. At this point, we want to use static. It's a very simple network. So we configure a static route here for this network. This is /32. And this will be the next hop. Okay, static route, you know it. So on R1, IP route to 6.6.6.6 /32 is 255, 255, 255, and 255. And the next hop is 10.0.0.6. You see, we are achieving reachability. Let's do that to see. And I don't even have to explain on R6 to do this config, because obviously on R6, you cannot ping this IP here, because this router and this network is seen to be behind R1. So on R6, we are going to use the static route to achieve reachability. IP route to the remote network of 1.1.1.1 and a /32. We pointed to 10.0.0.5. That's the next stop here. So let's do that to see whether we can achieve reachability. On R1, IP route to 6.6.6 /32. We drop the packet at .6. We come to R6 and IP route to 1.1.1 /32. Pointed to .5. Now let's do a pinging again. So on R1, let's see whether we'll be reachable. And there we go. Repeat 100. We are reachable. So please, all the time, if you are configuring BGP, ensure that you have reachability. So on R62, let's see whether we can ping the loopback of router 1. There's reachability. You can ping it. That's the output. So now let's go ahead to configure using the loopbacks. So configure terminal. Let's do it on R1 first. Okay. Router BGP. This is in an AS number of 50. AS number of 50. Neighbor, this time we are using the loopback of R6, which is 6.6.6.6. Remote AS. Please pardon me, my M is not working on my keyboard. I don't know why. So remote AS is 100. We go on R6 to do the same. Conf T router BGP 100. Neighbor 1.1.1.1. Remote AS neighbor 1.1.1. Remote. Please, who can repair this for me? My keyboard not working. The M, just the MO. Who can fix it for me? Huh? Any solution? Okay, so remote AS is 50. I've done these simple commands, just as we did for the
external keyboard.
I should do what?
External keyboard.
My table is too small for that. Okay, so we just did this simple configuration that we did whilst we were doing the peering for the interfaces. So let's see whether we have neighbors. What's the command? Show IP BGP summary. What has gone wrong? This is bad news. Is that not the same command we configured whilst we were doing the peering with the interface? You remember? Whilst we were doing the peering with the interface, it's not the same command that we used. That's the command we used. On R1, conf T, router, BGP 50, neighbor, the interface we use 10.0.0.6.
Hello, Sanat.
Hello?
Yeah, please check the AS numbers that you use for the remote BGP.
I should check what? The AS numbers, eh?
The AS numbers, yes. I think you use 100 or so. Oh, okay, it's 50.
So are you okay?
Yeah, yeah.
All right. If you are not sure, let's check. Show run. Let me pipe section BGP. So on R1, router BGP 50, neighbor, remote AS 100. Let's check this one too. Let's check this one. We just want to be sure, okay? Show run section BGP. And this one to router BGP 100, and the neighbor is in 50, so we are right.
Okay.
But there's nothing going on here. We show IP, BGP summary, and we are still in the idle state. You see? You see the difference between peering with the loopback and the interface? What has gone wrong? You see that because we are peering with the loopbacks, these loopbacks here, they are not directly connected, are they? Because loopbacks are perceived to be behind the routers. And that's a rule for eBGP the routers must be directly connected. They must, it's a must, be directly connected. That's if you are pairing. So the reason why we didn't have any problem with the .6 and .5, that the interfaces, they are directly connected. But we are pairing with this one, which is behind this router, and this one, which is behind this router. That is a problem. So we need a second command. On R1, we are going to issue this command here. Neighbor .6.6.6.6 update source loopback 0. So on R1, we are saying that to reach this neighbor, we are going to use this interface as our source of updating. So if you want to send any updates to this router, it will be via 1.1.1.1. So this will be our update source. We are going to issue this command here. On R1, then we'll go on R6 to issue the same command here, this one. So let's do that. R1, conf T, we are running BGP process of 50. So eBGP, router BGP 50, and neighbor 6.6.6.6 update source. We are using our loopback 0 as our update source. Okay, so on R1, our loopback 0 is the 1.1.1. We are good. We go to R6 to do the same thing.
So now, instead of doing update source loopback 0, could you do like update source 1.1.1?
Okay, let's try that. Okay, let's try that on R6 to see if it will work. Okay, so R6 config T router BGP 100. This running the process 100. So neighbor 1.1.1.1 source of update. Let's look at the options. Okay. This is loopback. I don't see. Okay, let's try this. I don't think it will work. There's no option. I'm not seeing any option here.
Yeah.
I'm not seeing any option here like that. So I don't think that will work.
No option.
There's an option?
No, there's none.
Okay. So neighbor update source loopback 0. We have this. So let's save. Now we are somehow confident that we'll move from the idle state, isn't it? Okay, let's check. So, and I want to see whether we have formed neighbor relationship. And what's the command? Show IP BGP summary. Still bad news. You see, so guys, take note. If you are pairing with loopback, the ball game is different from when you are pairing with interfaces. If you are doing that with interfaces, there's no problem at all. We are still facing idle. BGP is not seeing its neighbor. Okay, what is the problem? Now, because BGP is not directly connected, you have to tell this router that how can I reach this .6, even though there's a static route here, okay? But how far is it from me? How far is this .6 from me? Multi-hop. What are the multi-hops before you get to .6? We are assuming that .6 is one hop behind R6, isn't it? Let's assume this one is a loopback 0. Okay, let's assume this router, virtual loopback. Every loopback is behind the router. So from R1, what are the hops before you get to this one? Multi-hop, 1, 2. That calls for another command. So we are continuing the configuration on R1 here. Neighbor 6.6.6.6 eBGP. Where from this hyphen? eBGP multi-hop is 2. Okay, I'm telling R1 that, look, even though you have a static route, but we are assuming that that router is 2 hops away from us. BGP has to know. So we do this configuration on both R1 and R2 under the BGP process. Let's try that to see if it will work for us. So on R1, conf T, router BGP 50. Now neighbor 6.6.6.6 eBGP multi-hop 2. Enter. Let's go on R6 to fetch the same command. We're already in the BGP mode. So neighbor 1.1.1.
Boss, put the question.
Okay.
You know, sometimes I get very careful with the commands. The 2, where is it coming from, please?
Okay, we are just saying that 2 hops, the loopback is 2 hops away from R1. Okay.
Okay, boss.
We just said 1 hop and 2 hop because the loopback is always seen to be behind the router in question. You understand?
Okay, boss.
Yes. So let's do the same command on R6. Neighbor 6. Neighbor 1.1.1.1 eBGP multi-hop 2. Let's see. Let's check to see whether we will have some. There we go. We have some alerts. Good news. R1 has just discovered the neighbor 6.6.6 and the neighbor is up. So and show IP BGP summary. There we go. Good news. We have this. So we have learned how to form neighbor relationships.
Hello.
Yes, hello.
Question. Please, so does it mean that if you use the interface, you don't have to do the multi-hop?
No. Because the router, yes, you don't have to do it because the router knows it first-hand information. Okay. So if you want to write down some commands in our notes, let me just show run section. No, what did I do? Show run section BGP, and that's the command. We can just capture the command in our notebook to establish eBGP section using loopbacks. You see, using real interfaces is quite different from using loopbacks. So if you're using real interfaces, you don't need this command. You do not even need this command here. So let's take a look. Let's take notes. So today, what have we learned so far? We are still learning. As I said, I don't like reciting the features of a protocol before we start doing the configuration. We do it alongside. So right now we have seen that creating a session between eBGP peers, that's one using the interfaces and the other using the loopbacks, are somehow different. So anytime you are using this command, you know why you are using it. You understand it, okay? Why you are using this command, because the routers are not directly connected, and this R1, the router which you are on right now, needs to have an idea how far this peer is away from it. That is the reason for this command. And this update source, okay, if R1 is updating, its peer, that is its peer, this one here, it will use the loopback 0. Loopback 0 is the 1.1.1.1 to update. Okay. So now we can establish neighbor relationship between eBGPs. Now, BGP is such a fluffy routing protocol. Other routing protocols like OSPF, once they become neighbors, automatically they will start sharing updates, isn't it? They'll start sharing updates. Once they become neighbors, nothing will stop them. They'll start sharing updates automatically. BGP is not like that.
Hi, Nat, can I ask a question? So what would happen if you miss the number of hops, right? So now we have the hop to be 2. If you changed it to say 4, I mean, this is just topology. So assuming you missed the hop, would it change the states?
No, it won't change the state. It will work.
Okay.
It will work. Okay. Yeah, it will work. But in most cases, you have a rough idea how far the router is from you. Most cases. If you are peering with an ISP, most of the time is 2, because you have that direct connection. Okay.
Okay.
All right. Please, our time is almost up. We will connect again, but give me some 5 minutes. Let me drink water. Okay. It will disconnect very soon. In about 2 minutes time. Don't go away. 2 minutes time. I'll be back. Okay. Just drinking water.